Hi everyone, today I'll show you how to determine whether a series is convergent or divergent. So the problem that we have is the series of n equal 1 to the infinity of n cubed over 5 to the n. Now this problem I will use ratio test because it's very easy to use this test to find our final answer. Now we only have 3 simple steps to go through. And the first one is to find the limit when n goes to infinity, and then we put the absolute value of the an plus 1 times 1 over a to the m. Now an plus 1 means that we need to add plus 1 to each n we have in our function in here. So we will have n plus 1 to the third over 5 to the n plus 1, so 5n plus 1 times. We need to put 1 over a to the n. So 1 over the function in here, and then we need to flip it, so we'll get 5 to the n over n cubed. Now the second step is to simplify, and when I say that is to open the exponents in here, and it's just using the exponent simplification. When we have the same base, we can add the exponents together or open them up together. So we will get limit when n goes to infinity of this quantity. Now we cancel the 5 to the n right here. We will be left with n plus 1 to the third over 5n cubed all to the absolute value. Now the absolute value is in here. It's not necessarily to have it because everything inside our absolute value is positive. So the third step is to find the limit, and when I say finding the limit is just to plug in the infinity here. When we plug in the infinity, we'll have infinity over infinity, which is indeterminate, and so we need to use algebra or any other techniques to find our limit. So the technique I used in here is the L'Hopital's rule, and L'Hopital's states that when we have infinity over infinity or 0 over 0, you need to differentiate the numerator and the denominator separately. So the derivative of this part is 3 times n plus 1 to the second, because it's the chain rule, and the derivative of 5n to the third is 15n squared, which is the power rule. Now cancel out these two numbers. We will have the limit when n goes to infinity of n plus 1 to the second over 5n squared. Now if we plug in the infinity, we'll also have infinity over infinity. We'll go through L'Hopital's again, differentiate each part separately, so we'll have 2 times n plus 1, the chain rule again, and this one is 10n. Simplify again, and you will get a limit when n goes to infinity of n plus 1 over 5 to the n, 5n. Now the limit, if we plugged in the limit again, the infinity again, we will get infinity over infinity. So we need to go through the L'Hopital's rule the last time. Now we will have limits n goes to infinity 1 over 5, and we know that the limit of a constant number is the constant itself. Now this number will determine our series whether it's convergent or divergent. Now because it's less than 1, so our series is convergent by ratio test. Now the question was asking whether the series is absolutely convergent or conditionally convergent. We need to state that our series is absolutely convergent because we used the absolute value in our solution. But because the question was only asking whether it's convergent or divergent, we just need to put it's convergent. I hope that was helpful. Thank you very much.